but we use the popular Python framework to implement this model. This is a snippet that we have used during the coding part of this project.
All right, so we have two parts in this project. One is the actual neural network, which will do the recognition of the characters, which is what he explained to us. And to train that network, we use the dataset that Adri explained to us, which is the MNIST. And basically, that dataset is presented like this. It's basically images of 28 by 28 pixels with this shape and with actually the background in black and the letters in white. So basically, we have to go from one image, one picture of image, to this to be able to recognize characters, right? So there's, apart from the neural network, we have also a lot of computer vision tasks that we have to do in order to process the image and to be able to predict the actual letters. To do that, we have to go through all pre-processing pipeline, which starts there on the top right there. Original image, we change it, we pass it to grayscale, then we have to deal with lighting conditions because you might have like part of the image darker or lighter. So we have to have an adaptive threshold. We have to delete the pixels to make the image sharper. Then we have to split the lines to be able to separate them. Inverted thresholds, we have it like on a similar format like the final results. But after that, we probably end up with an image which is not exactly the shape we need to use to put it through the network. So we have to make sure this actually gets the right size. And after that, we get from this the final result, which is this. Now, at the beginning, we find that first, since we have the data set unbalanced, we have a lot of problems with the digits. So 0, 2, 0, 1, 2, 3, and 4, and 2 lines are going to probably be more predicted instead of characters sometimes. In this case, we also found that the pre-processing is really, really important, because if the image you put in is not as good, the prediction is not going to be exactly that good. And we have, from this image, this is what we got, the first try we did. So here we can see, we did a good job here. This is, well, couldn't really get it. But in overall, well, that wasn't great. For the second line as well, it wasn't great. So we said, okay, we need to increase pre-processing. We did the same here. This is the actual same image, but the characters are a bit sharper, are a bit better. So it's still not perfect, but we can see how it improved already. So there's only one mistake here, basically. And if we will have just gone all to lowercase, it would be perfect. Like here we actually have the probabilities of the prediction we got. And we can see that, like for example, here where he actually predicted the Q, he just said, I mean, he's on the 70% accuracy. Like when he went to the B or A, B is like 99%. More simple things. Here we can see one example of the bias. It's predicting a 0 instead of an O. Like for uppercase and this type, this was perfect. It was okay. Now, more examples here as well. Like for example, the S. We found that for really small changes, he will predict a 5, because I mean we can even see like. But also we can see that the probability for the 5 is really low. So probably he will have guessed. There's like a second chance to second probability probably. Here as well. The I, he predicted as a 1. The O was a Q. And this time he actually got the S. It's not the Q, but you can see it. This time the S actually is correct. That's correct. Because we are pretty well. So this is our project. I hope you guys enjoy it. Thank you.
No, one question I said.
Yeah.
I have a question.
Go for it.
How would this code work with different languages?
With different languages? Well, I mean, right now, it's not about the language. Right now, it's about the alphabet used, because we can recognize English characters. So basically, we are recognizing characters, not words. So there's not a problem with languages unless you want to put Japanese, Chinese, or Cyrillic, of course. Then you will need to train a model with those characters.
Okay.
Right now it's trained for English characters.
Thank you.
Can you hit the next slide? Perfect. So give them an applause and give the floor to the next topic.
Hello everyone. We are the mobile phone data footprint team, and it really means nothing. What we did is about taking the mobile phone raw data, and we analyze the mobile phone data, and we get some relations with the weather in the city. And the team we are Jordi, Cristina, Edgar, and Matthias. And our main objectives was basically extract the raw data from the mobile phones and analyze that and clean it and cleansing to organize the database. Secondly, analyze the data from the mobile phones to get from that mobility patterns, to analyze that patterns and then match with another things like the weather, and finally train a neural network to match the mobile phone data, that patterns that we get, and the weather patterns, and get from that some correlations to I'm explaining very bad, sorry. Let me try to explain again what we do, okay? We have data from our mobiles, and we get from that some pattern mobility from all the people that are around in the city driving. Then we get from a mobile, from a website, data from if it's raining or not during all that years, and then we match to get if the patterns from the people that are in their cars change depending on the weather, if it's raining or not. Okay, now it's more clear. Okay, so we doesn't have any partnership with Google or Facebook, so we have to get our data, and the information from mobile phones we get from the Transparency Catalunya, that they give us a big database to analyze, and for the weather we scrap it directly from the website. So we used a few technologies like MongoDB to clean and to manage the database, Panda to filter and to organize all the data, Beautiful Soap to scratch the information from the weather website, Seaborn to create heat maps, and the neural network we use TensorFlow, and we are gonna explain it later. The process we separated into two main processes. One to analyze and to get the mobile phone. And you will see that it's in blue, and at the top of each slide, that you will see that the slides related with the mobile phone are in blue, and the slides related with the weather are in red to know where you are. So the process is almost the same. We get data, we clean it, and we prepare the database to compare at the end with our trained neural network.
Yeah, so when we downloaded the data from the GenCat webpage, we got 11 million registers, and then we clean all the data, and we just focus on the fields that we really needed to work with. And then we just selected the ones that were inside Barcelona, so we reduced the database to 3 million registers. And then we loaded into Panda's data frame, and there we again filter just to those registers that were on vehicle, because we want to study the mobility in the city, and also the ones that were on weekdays, because we think that the city changes a lot on weekdays and weekends, so we just focus on weekdays. Okay, so after that we created some heat maps with Seaborn, and so on the left you can see the images we have been using to train the model, and on the right it's just a volume heat map so you can see Barcelona, but we haven't used those images. To create the heat maps we just needed to have the coordinates and the amount of registers that we had in each coordinate at that time. So we generated these images. Initially it was just 2 images per day, so one in the morning and the other one in the afternoon. We had to change that in the end because we needed more data, so we will explain that later. And also you can see some points on the axis because we had some problems with, since we don't have the same amount of points, when we generated the heat maps, the zoom scale was different all the time, so we had to make this amount of points to all of the registers, all of the dates, so we could have the same zoom. Yeah, so then when it comes to the weather data set, we took all the data from this website, Time and Date, and we used a beautiful SOAP library to get all of the tags that we really needed, like the time and date and the description. Yeah, so finally we got this small pandas data frame where we could just select the descriptions that matches with the rains depending on for each day. So afterwards we had these 2 data sets, the images and the weather data frame.
Now it's time to combine. Sorry. Before combining the information, we had to pre-process all the data because we identified that there was some days with few registers, then there were few points, as we can see here. We cannot recognize the city on this image. It was removed from the heat maps, this low number of measurements, 1st of January, for example, 2nd of January, and so on. National holidays and local holidays were removed as well from the dataset because being during the weekdays, in the middle of working days, it was included as data for analysis. Then we needed to create the heat map augmentation as well because we're in Barcelona, you know. So mainly there are sunny days, few raining days, then it was required to generate additional information. For that, as Christine explained, we instead of doing images twice per day, we increased the numbers, doing some gaps of images 3 hours in a row, then another 3 hours in a row, and to generate from 7, 8, 9, 8, 9, 10, to generate different samples. And then the next step was to combine the heat map images with the weather history. And then the result, as we can see below, is that, okay, we have a lot of sunny and few raining. Then what we did is to do, because we did before the augmentation, we reached at the same number, and we created the 2 samples at the same size. And then once we had the images and the labels, we combined in a neural network. It was done with Keras. We did 3 convolutionals with batch normalization, ReLU, and pooling, and then we did the classification. The initial image was reduced to 280 pixels by 280 pixels in order to make easier to analyze by the neural network. And with this neural network, we reached to a 60% accuracy. It's not great. You should consider as well that the samples that we get were limited, and also the precision, the amount of data, the measurement was not really accurate. We were starting with 3 million points of reference, but it's a few number compared to 3 years, that was the period of analysis. And with more data, we assume that we will improve the accuracy. When we did the data augmentation, we realized that the neural network increased the accuracy as well, from 50 to 55, and finally with the batch normalization and the dropout to 60. And as a requirements, as I said, we had to increase the image resolution. Initially we thought in low resolution images, but it was impossible to recognize the city. And with this, it was able to recognize the city and recognize the streets, and it was easier for the neural network to identify the different roads and the density. What we learned from this project is that the low amount of sample data is impacting the accuracy, the batch normalization improved the learning rate, open data information is available, and it's something that is becoming more popular due to public and corporate transparency. That means we'll be able to everybody to access to this data to create their own projects. And IoT devices are increasing a lot, and there are a lot of sensors in the city and the people to measure, to take measurements, and also to analyze. The uses of this project is to help traffic, for example, to help traffic distribution, to predict mobility flows, to manage traffic lights, for example, with no investment almost, because everybody is carrying a mobile phone on the pocket. And at the end, the council doesn't need to put a lot of sensors in the city. Just the people have their own sensor and is collecting this information, that's all. And other uses that we identified is for cultural events, football matches, and every event in the city can be recognized on that. That's our project.
I would say as well that it's really, I think, amazing when I saw the application is that you guys are scrapping from the website. They're targeting the HTML tags. So basically, essentially, it's an end-to-end application. They build their own database. You can basically, if you think about what do you like, movies or the books that you read, you get to that page, you target the specific links, they download it, they pre-process it, and they teach it to a CNN, and it gets them a result. So I think it's a really, really impressive task. So congratulations on that, guys. And I don't know if someone has any question regarding this topic. Okay. So we'll move on to the next project. Please give it a shot. And the next project we're gonna have there.
Okay, hello, good evening. Our project for AI Saturdays is called Asset Price Prediction using an LSTM neural network. Okay, and basically what we were trying to do here is to resolve one of the most complicated problems in machine learning. There are many more, but this one is one of them. It's about predicting the future, and it's very important, even though our project was based on analyzing data from the financial world. It's very important that we ignore that for a moment and we remember that this is mainly something that will allow us to apply this knowledge to absolutely any kind of asset whose price fluctuates over time. Okay? So, having said that, this is our mission initially. What we are trying to do is to create a model that can predict the future potential price of absolutely anything that fluctuates over time in a way that is just a little bit better than random. If we get it better than 50%, we've already got something positive. We are already building something on, and this is as much as we want to do with this project. Now, it's very, very important, and one of the first things that may come to your mind that, of course, the analysis of past data doesn't necessarily mean anything looking towards the future. Okay, whatever has happened before may not happen again, and there are what are called black swan events that may have a very strong or important impact in absolutely any kind of market, regardless of what we're talking about. When that happens, then whatever prediction we've done, basically we can throw it out of the window because there's absolutely no use to that. We knew that from the beginning. We bore that in mind, and it's totally natural that this is something that you will wonder. However, it will be important to know that it's also most probably not a mission impossible. There are companies out there that are doing it in different ways, using similar prediction models, For example, this one is one of the examples in the financial world. This company called Renaissance Technologies has been doing something similar for many, many years. And Google has applied one of these similar models to this one to minimize and reduce several-fold their costs in regulating basically the heating and air conditioning costs that they have in their data centers. Now, as I said before, it's very important to know that this can be applied on many different fields, and we're going to talk about them later. Oil, water, power, wind, soy, coffee, solar. Imagine that we are a local government somewhere in a developing country, and we depend on buying wheat or electricity or whatever we need to buy tomorrow. It would be useful for us to know about the price of that asset today. Well, if we will have this technology, and this technology will be precise enough, we could perhaps make investment decisions by buying those grains or electricity or whatever today, knowing that tomorrow it will be more expensive. The model will give us a sign, either buy today or don't buy today because tomorrow will be cheaper. And this is what we're trying to do. The applications of this, naturally, financial applications, digital currencies, but also, very importantly, scientific analysis. We can talk about the natural world. We can analyze the weather. We can analyze migration of birds. There are lots of different things that we can do with these kind of models by basically predicting where a trend is going. As long as we can do it, as I say, better than chance, we already have something valuable. Now, the limitations, naturally, of any kind of model like this is several-fold. First of all, we have to make sure that we have the right data to begin with, that we got plenty of that. We have to make sure that we are applying the right deep learning framework, in this case, and we have to make sure, naturally, that we have enough computing power available in order to get the predictions that we want in a timely manner. Okay? Now, for this particular exercise, what we did, the easiest way for us to do it for this project was to take financial data. In this case, we just took it as a sample to make sure that we could do something like this, to see how we could learn more about these models. In this case, we used the Apple stock price for the last few years, from 2013 to 2018. We used daily stock prices, the open mainly, and the source was Yahoo Finance. Okay? The pipeline and the tools that we use. It was a long short-term memory network because we found out, as we wanted to make this kind of analysis, we learned that this is a time series problem. One of the best tools to do that will be an LSTM. We implemented Keras. We use Keras to do an implementation of TensorFlow, and we use approximately 9 to 10 layers. We had dropout layers, we had conventional layers, and we had a variable number of epochs. We will talk about that later. Now, our results are preliminary. I must let you know that because this is such a complex problem that we are still working on it, interestingly. In fact, even though, as you can see on the graph there, we seem to have achieved a very interesting kind of precision, our prediction there, this is not necessarily true or correct or right. And this was one of the things that we learned doing this project, that not everything is as easy or as good as it seems on the first time. Otherwise, this would be an easy problem or everyone will be doing it. So, once we had the basic implementation of the network, we simply explored. We played with the different parameters of the system, of the model, to know what will give us the best results. We simply tried, on a first instance, we tried number of epochs, and we tried batch size, and we play with the basic parameters. Based on this, as you can see, we could get different levels of precision on the predictions, okay? And we tried more epochs, less epochs, bigger batch size, smaller batch size. As long as we stuck to the main LSTM network, and we didn't want to get out of that. We tried pretty much a few different combinations of models. Naturally, of course, the combinations that we could do with tuning the parameters is exponentially large, perhaps infinite. So it was very important for us to stop at one point. So basically, due to our limitations in computing power, because we were doing this on our own computers, we just tried different things, and in the end, we got to this one. And this one, as you can see, and this is the key of the story, as you can see, graphically, it looks really good. It looks really interesting. I remember when we saw this, we were like, wow, if this is predicting with that level of accuracy, the prediction is following the past price so well, we may have something interesting here. However, and this is the most interesting thing that we learned in this project, is that we saw, and after Hermes or Albert can comment this with you, but we saw that the machine may be playing a little trick with us, without intention, of course, which was that perhaps, and we noticed, and this is one of our theories, that the machine, the system, is simply taking some of the last prices and giving us a prediction that is similar to those last prices. Somehow doing just a time series analysis, but just moving the price that it has seen recently to predict that the next price will be within that range. And this will also explain why the graph looks like that. So, this is a project that is still ongoing. We have achieved certain interesting results, but naturally, the most important thing of this project is to learn things. To learn things like when you are trying different codes that people have done more advanced implementations there, the code may not work at all. And this was one of the things that we saw and that we chose not to go with. The choice of tools may not be optimal, and we may also have code that is not properly explained. This is also a problem in something that doing this project we have learned. It's very, very important that we all comment our code properly, because you never know who may come after you wanting to see that code and they don't really understand anything of what you've done really. Now, finally, looking ahead, there are a lot of things that we could do, and this is what we are still working on. Okay, ideally, if it's any kind of asset that depends on the opinion of people, for example, assets in the financial world, adding sentiment analysis to the model could be very interesting, and it could boost the accuracy of the model. We could test different algorithms, different epochs. There are lots more things that we could do with this model, but the interesting thing is that, for me, personally, the most interesting thing on doing this project was that some people would say right from the beginning, this cannot be done. Some other people, however, will say, maybe it can be done. Let's explore how it can be done. So I think that it can be done. We are halfway on doing it there. There are still lots of things that we can try, and I invite you, if you have any new ideas or you're interested in this field, to comment it with the team here. But surely there are ways when we add the current sentiment to the analysis of historic variables, there are ways to, through the right models, apply the right techniques to get predictions that are better than chance. Now imagine if you are the local council in some country, developing country, and you need to buy this grain, and it's almost a life or death situation for you to know this information, how valuable that is. So with that final thought, I leave you remembering the potential social impact of something like this. We only concentrated to do this exercise on the financial world, but it can be applied on many other ways that can help the world to be a better place. Thank you.
Since we are a bit shy with the questions, does somebody want to ask a question? Yeah, you got a t-shirt. So we'll do that.
I don't need it.
Okay, okay.
I have one. Do you want to ask a question?
Yeah, actually, my question is, what is the application that you guys are thinking for this project? Because I see that you're about to share a prediction about a stock market price or value, right? So that means that at the moment that you share, that prediction is already changing, right? Because if you share that something is going to be raised or something is going to be dropped, now talking about value, that prediction doesn't work anymore. So you share that already changed. I mean, what is your application for that exactly?
Okay, our intention is, if we develop this project, is not to make immediately the predictions public to everyone. Instead, to use and get a financial profit of this prediction, because as you well said, the financial markets are a chaotic system, and if the same information gets public to everyone, then the price will reflect all the available information. So it's not the intention to share the price, the predictions, but to use it in a profitable way.
You all like buy like some stock market from their company.
So
Have the prediction
we need to work on
already.
the social impact side, but luckily we asked them to put the projects on GitHub, so you can copy it right now before they can take it down, because they are busy with the presentation, and then you can apply this for your own social good.
It doesn't work anyway, so.
Okay.
Don't
Can you
say
do that
that.
later?
Later.
Yeah. Let's do one question per group, just so that we ensure that they have the equal amount of time. And later on the networking, you can do more questions. The next project that we have is the charging everywhere with electric vehicles, which I believe is based on a real data set that Place to Plug provided them in order to measure and predict whether the timings at which those vehicles would be charging. Please give them a round of applause.